Hello and welcome in the next video. Now in this video we are going to solve general aptitude question which are asked in the GATE examination. Now here in this video I have taken all this question from GATE paper MT. Here this MT is corresponding to the metallurgical engineering and the year of this question paper is 2022. So now let's solve the general aptitude question from this paper MT metallurgical engineering. So now let's start the video with first question. Question 1 says Mr. X speaks, okay, and we have one blank and Japanese, another blank and Chinese. Okay, so we have one unknown person we call as Mr. X, and we have two languages, Japanese and Chinese, and here we have two blanks. So simply we have to fill this blank. And now here look at the option. The option are given in this neither, or, either, nor, neither, nor, and also but. But now here simply you can see if we put here in this first blank as neither, then our sentence will be Mr. X speaks neither Japanese. And here now here in this first option here the second word is or, but now here it look like something different because our sentence will be Mr. X speaks neither Japanese or Chinese. So now here or is denoted for the alternative option, but now here we are declining either here in the first blank as neither. So must we have to put nor here to decline these two languages simultaneously. So now we can say option C contain the correct set of word for those two blanks, because if you put neither here in this first blank, neither and nor. So now read the statement. Mr. X speaks neither Japanese nor Chinese. And yes, it will make sense because this Mr. X is not able to speak Japanese, and also he is not able to speak Chinese language. So we can say option C contain the correct set of word that can be put on this two blanks. Let's move to the next question. Okay, so question 2 says a sum of money is to be distributed among P, Q, R, and S in the proportion 5 gem, 2 gem, 4 gem, 3 respectively. So now question says we have some specific amount of money, and that money is distributed among those 4 persons P, Q, R, S, and this money is distributed in some particular way, in such a way that the amount of money that person P will get, Q will get, and R will get, and S will get is in this proportion. So we can say P gem Q gem R gem S. Here this we are taking the ratio of the amount of money that the individual person will get, and now this ratio is in this proportion 5 gem 2 gem 4 gem 3. So now here we can say the total amount of money that person P will get is nothing but we can write the amount of money that this person P will get is nothing but just simply 5 times any general constant. So we can say the amount of money that person P will get is nothing but 5 times K, and we can say here K is nothing but any general constant, and here this K must be positive and real because we are talking about the money. So this K is positive and real. And now we can also say the amount of money that this person Q will get is nothing but 2 times this constant K here, because the corresponding ratio for this person Q is denoted with 2. So we can say the amount of money that Q will get is nothing but 2K. And here again this K is the same constant, which is for this person P. In the same way I can say the amount of it that this person R will get is nothing but 4 times this constant. In the same way the amount of money that person S will get is nothing but 3 times this constant. So now here let's read this question further. Question says if R get 1000 more than S, what is the value of share of Q in rupees? Okay, so now here we have one condition. If R get 1000 more than S, so now here this condition is given to us to find this constant K here, because they are asking the total amount of money or share that this person Q will get. Now to find the total amount of money that the person Q will get, we must know the value of this constant K here. So now here we can find out the value of K with the help of this statement. So now we can decode this last statement into mathematical equality. So we can say the amount of money, we can write amount of money that R will get. So now statement says R get 1000 more than S. So we can subtract 1000 from R money and equal to, we can equate this amount of money is exactly same as the amount of person S, amount of person S. So now simply we can replace this term. So amount of R is nothing but 4 times K. So we can say 4 times K minus 1000 equal to the amount of money that person S will get. Here the amount of money that person S will get is nothing but 3 times this K. So we can say 3K. So we can simply simplify it. So we can say K is nothing but simply 1000. So now we have find out this constant K here. So simply we can easily say the share of this person Q is nothing but 2 times this constant. So we can say the amount of money that Q will get is 2000 rupees. And now here we are talking about the rupees. So we can say the amount of share for this person Q is nothing but 2000 rupees. Now let's move to the question 3. Okay, so question 3 says a trapezium has a vertices make as PQRS. Now here this word trapezium is nothing but simply just four-sided figure with four corners. And now here these four vertices are named as PQRS in that order anti-clockwise. So now here this order, we must have to follow this order into this in anti-clockwise direction. The side PQ is parallel to side SR. So now let's try to draw the trapezium based on the information given in this question. So we can say here this PQRS are nothing but the vertices of our trapezium. So now we can start with the point P, because here we have given the sequence for these vertices. So we can say here this point is P, and now the second point into the anti-clockwise direction will be Q. So we can locate Q somewhere here. So we call it Q. And now here, so this figure is trapezium. So we know the trapezium has four sides. So we can simply connect those 2 points to make one of the side for the trapezium. So now here let's shift this point P here. So now we have drawn one of the side for this trapezium. So now the question says if side PQ, okay, so we have drawn side PQ is parallel to side SR. So now let's, our fourth point it will be R. So now here R may be located somewhere here in this side. So here R may be the above this point Q or below this Q. So now let's draw this trapezium in any general way. So we are assuming that this S is below this Q. So now here we can say this point is nothing but our R. So now in the same way we have to draw on the last point S. Again we are assuming this S is above the P, because now if you read the question further, we have given the dimension. Further it is given that this PQ has length of 11 centimeter. So now this side has dimension of 11 centimeter. And now the further information is given is RS, which is nothing but simply this line connecting those 2 points. Now the dimension of this line is 6 centimeter. So now we are sure that this SR has smaller dimension than this PQ, but we are not sure whether where we have to put this line, whether the above this point or below this point. But in general way we are putting it here. Now let's connect this R and Q also to make our third side of this trapezium. In the same way we can also connect this S and P to complete our trapezium. So now the dimension of this RQ is given as 4 centimeter. So we can see here it is 4 centimeter. And now here the dimension of this SP is given as 3 centimeter. So now we can easily see these two lines are inclined. But now here the dimension of this RQ is more than this SP. Then we can say this line is inclined more than this line, because those two lines are parallel. That means the distance between this PQ and RS must be constant. So we can say this top line must be more inclined than this bottom line. But now what they're asking what is the shortest distance between PQ and SR. So now here condition is given that this PQ is parallel to RS or SR, in other word. But now here they are asking the shortest distance between PQ and SR. That means we have to find the shortest distance between those two parallel lines. But now we know for any two parallel line, the minimum distance between any two parallel line is nothing but the perpendicular distance between two lines. So now here we can say if I draw the perpendicular from first line to the second line, then this distance will be the minimum distance. Let's call it D. So now here the minimum distance between those two lines, let's call this line L1 and this L2 is the perpendicular distance. Now if you select any other point like this and you connect those 2 points, so you can easily say here this distance is must be larger than this one, this D, because it is nothing but the combination of this perpendicular distance plus this distance. So we are getting this distance. So now simply we have to find the perpendicular distance between those two parallel lines, and here the parallel line is PQ and SR. So now we can draw perpendicular line in this way, and here this angle is 90 degree, because we know the minimum distance between any two perpendicular line, sorry, two parallel line is nothing but the perpendicular distance between them. And here let's denote this distance D. So now simply we have to find this distance D here. So now we have to decompose this figure into little chunk to find this distance D. So now here the first step is that we can make the triangle here at bottom and also at the top, because so let's simply draw the horizontal line from this point S toward this PQ line. So now this line will be intersect this PQ at somewhere here, and again this distance is, sorry, this angle is right angle, because we know the perpendicular line between any two parallel line, sorry, the shortest line between any two parallel line must be at right angle. So now here, so this angle is nothing but our right angle triangle, and we know hypotenuse. Simply we can assume this distance from here to there, this distance we can assume as x, because we don't know the value. So simply we can say here this distance is x. In the same way, I can also do the same thing for the top, for this figure also. So let's draw again the horizontal line from this point R toward this PQ. So now again this angle is 90 degree. So now again we know the hypotenuse. Simply we can again we have to find this distance. So now but this portion of this figure, let's draw in another color. So now this portion from R to S and this distance from this line to this line. Now those two lines are parallel. That means if the left hand side is 6 centimeters, then right hand side is also 6 centimeters. So I can say here this blue portion on the right hand side is nothing but simply 6 centimeters, and this portion is x. And I know the total length of this PQ line, which is 11 centimeters as given in the question. So I can easily say here this dimension of this Q is nothing but simply 5 minus x, 5 minus x, because simply we have to subtract 6 and x from the 11. So we can say that this distance is nothing but 11 minus 6 minus x, because this distance is 6 and this one is x as you assume. So now we know this dimension also, and here this distance is also d, and this distance is also d. So now simply we have to use the Pythagorean theorem twice. One time for this upper triangular, that's denote as 1, and second time for this one. So now for this first triangle, we can say the square of this 4 will be 16, equal to the individual sum of the square of this side. Here this side is d, so we have to d square, and here this side is nothing but 5 minus x, so also we have to square it, 5 minus x square. Now we can also apply the Pythagorean theorem for this lower triangle, which is named as 2. So now here the left hand side will be 3 square, and here it will be 9. The same way here d square plus x square. So now simply we have 2 unknown and 2 equation. We can easily find 2 unknown here, but now simply we can replace this d square here from this equation. So we can say d square is nothing but simply 9 minus x square. So let's put this d square here. So we can say 16 equal to 9 minus x square. Now let's also expand this bracket. So I can say 25 minus 10x plus x square. So now here this minus x square will cancel with this plus x square. So now we end up with this term. Here the left hand side will be 16 as it is. 9 plus 25 minus 10x. So now we can say 10x equal to this 9 plus 25 minus 16. So we can say it will be turned out to be 18. So now here the value of x is nothing but 1.8. So now we have find out this dimension here. So we can say this x has a value of 1.8. So now easily we can find this value d, and it is our main focus because they are asking the shortest distance between those two parallel lines. So simply put this x here in this first equation to find the value of this d. So I can say d square is nothing but 9 minus 1.8 square. Now if you do the arithmetic, then you end with d is nothing but 2.40. So now the minimum distance between this parallel line PQ and SR is nothing but 2.40. So you can say option B contains the correct distance, which is shortest distance between those two parallel lines. Okay, now let's solve question number 4. So question 4 says the figure shows a grid formed by the collection of unit square. So now here we have given one figure, and now here this line are nothing but simply the grid, and this little square are the unit square. Now it has dimension of 1 unit by 1 unit. The unshaded unit square in the grid represent a hole. That means here this portion is nothing but a hole. So we can write here this unshaded region is nothing but simply hole. So you can think like this is nothing but our metal plate, and here we have divided this plate into this unit square by one dimension, 1 unit by 1 unit, and we have cut out material from here at this point to make the hole in this plate. So now the question is that what is the maximum number of square without a hole in the interior that can be formed within the 4 cross 4 grid using a unit square as a building blocks. So okay, now they are asking the what is the maximum number of square we can build from this figure with the help of this unit square here, this unit square. But now we have to build this unit square in such a way that this hole must not be included in any particular square. So now here you can see we can solve this problem by the method of permutation and combination. But now here the figure is small, so we can easily count the number of square here. So it is easier to count directly. So now let's count here. So now in the horizontal direction we have 4 unit square, and in the vertical direction we have again 4. So we can say the total number of unit square here is 1 cross 1 here. So it is our unit square here, this one. So now here how many these square are there in this figure? So I can say 4 cross 4, and it will turn out to be 16. But now here we have cut out one square here, and we have made as whole. So we can subtract from here 1. So we can say this 1 cross 1 unit. So we can write here the unit. Okay, so now let's make a table here to understand better. So now here we can simply, so now here we have to put the dimension of square, and here the number of square that we are getting from this figure. So now here this represent our dimension, and here this second column is representing the number of square. So now here let's number of square. Let's start the dimension with 1 unit cross 1 unit. Simply we are counting the smallest square that we can get from this figure, and here this smallest smallest square is nothing but 1 unit cross 1 unit. So now here we are getting a 15 square of that dimension 1 cross 1. So now let's move to the higher dimension. So now our next dimension is nothing but 2 cross 2. So that's mean 2 units in the horizontal direction and 2 units in the vertical direction. So now we can see here we can make in this way. So now here it will represent our first square. The same way we can also draw here the second square. The same way we can also draw here our third square with this 2 cross 2 dimension. So now we can place 2 here, 3 sorry, 3 here because 1, 2, 3. So now let's observe this figure carefully to find out the more 2 cross 2 square. But now here we cannot include this square, this 2 cross 2, because now if we try to make this square, then it contains this hole inside of this square. And now here the question says we have to make the square in such a way that without including this hole in the interior. So now simply we are not considering this square. But now look at the carefully. We can also select those 4 little square here in this way to make 2 cross 2 square here. This one. So now we have to add 1 because we are getting this extra one. Now in the same way I can also construct here in this way like this green one. Again which is 2 cross 2, so again I have to add plus 1. So now that's it. Now if we move to the higher order, which is 3 cross 3, 3 unit in the horizontal direction and 3 unit in the vertical direction. Now whatever the square you select from this 3 cross 3, this whole must be in the within this square, because whatever you get like this, it must include this hole, or in the other word, or in the other way you can also try from any corner, you still include this hole. So now we can say here we are getting 0 square. In the same way for this 4 cross 4, again we are getting 0 square. So now simply we have to sum all the number from the number of square. So we can say 15 plus here we have 5. So we can say 15 plus 5 is nothing but simply 20. So now the number of square that we can build from this grid without including this hole is nothing but simply 20. You can say option B is the correct one. Okay, now let's solve question number 5. So question 5 says an art gallery engage a security guard to ensure that the item displays are protected. So now okay, we have one gallery and we engaged one security guard to ensure that the product that are placed in the gallery must be protected. The diagram below represent the plan of gallery. Okay, now here we have a triangular shaped diagram. Now here this diagram is nothing but simply our plan of our gallery, where the boundary walls are opaque. Now here the boundary walls of this gallery are opaque. The location where the security guard posted is identified such that all the inner space shaded region in the plan. So now here this darker region in the plan is nothing but our interior portion of a gallery. So now we can has this boundary because this wall are opaque, so we cannot see what is behind this wall. Simply we can shade in this way. And now here this darker portion is our interior part of this gallery. And now here the question says we have to put the security guard in this gallery in such a way that the gallery is within the line of sight of the security guard. Okay, now here we have given 4 points, this P, Q, R and S. Now here this we have to select those points from those 4 points in such a way that if we put our security guard at that particular point, then our security guard must be able to see the whole gallery. So now here further condition is given if the security guard does not move around the posted location. Okay, so now here this statement says this one, wherever we put our security guard, our security guard does not move from the posted location. That means the position of this our security guard must be stationary, and it has 360-degree view. And now it has a 360-degree view. That means our security guard can turn around 360 degree. It has 360-degree view. That means wherever we put our security guard does not move and he can turn around 360-degree view. Which one of the following correctly represent the set of all possible location among the location PQRS where the security guard can be posted to watch over the entire inner space of the gallery. So now here we have to select the point in such a way that if we put our security guard at that location, then our security guard is able to see the entire gallery, and we have to focus on these two conditions. One condition is that our security guard does not move from the posted location, and the second is that our security guard has 360-degree view. So now simply let's start with this point P. So now what happen if we put our security guard at this point? Now here our security guard is able to see this area here in this way. I can say here because here this area is nothing but the directly front side of this guard. In other words, this area is directly in line of sight of this security guard. But now here, what happening at this point in this second corner of this gallery, this security guard does not know. Simply we can cancel out this point P, because if we put the security guard here, it can see all this area. But now here, we cannot see what happening at this second corner at this R position. So we can cancel out this point P. In the same way, we can also cancel out this point R, because the same happen with the R also, because the security guard will able to see this whole portion, but he will not able to see what happening at this point because these holes are opaque. So now we have cancelled out the 2 point, and we remain with this 2 Q and S. So now here if we put our security guard at this point Q, this one, so he can see this portion directly, also see this portion directly, and also he can turn around this position, so you can also see what happening at the back side. So now yes, Q is the one of the location where we can place our security guard. In the same way, Q is also one of the location that we can also engage with the security guard, because this side is again directly in view of the security guard, and again here this security is also going to turn 360 degree, so you can also see what happening in this lower corner of this gallery. So we can say Q and S are the two location where we can put our security guard to ensure that whole gallery is in the sight of this security guard. So we can say Q and S are the 2 points. So option C is the correct one. So this question is asked for the 2 mark. Okay, now let's solve question number 6. Question 6 says mosquitoes pose a threat to human health. Controlling mosquitoes using a chemical may have undesired consequences. Now here they have given this statement: controlling mosquitoes using chemicals may have undesired consequences. That means they are affecting in the negative way. In Florida, authority have used genetically modified mosquitoes to control the overall mosquito population. It remains to be seen if this novel approach has unforeseen consequences. Now here, this sentence is also important. It remains to see this novel approach has unforeseen consequences. Now here, this statement simply says we don't know what is the outcome of this genetically modified mosquito, because we have not enough data for this kind of new approach. So now here we are not sure what happening in the future, whether this novel process may affect the society in the positive way or in the negative way. We are not sure at this point. Which one of the following is correct logical inference based on the above information in the above passage? So now for here we have 4 options. So simply we have to select the logical statement that we can say from the above passage. So now let's start with the option A. So now option A says using chemical to kill mosquitoes is better than the using genetically modified mosquitoes, because genetic engineering is dangerous. Now here this last statement is declaring the result of this novel approach. But now here in the passage it is given that it is remain to see. That means we are waiting for the result. But now here in the option A they have declared the result. They have simply given this genetic engineering as dangerous. So we can cancel out this option because we are not sure what happened in this case. So we can say this statement we cannot say from this passage. So now let's move to the option B. So option B says using genetically modified mosquito is better than using chemical to kill mosquitoes because they do not have any side effect. Again the same thing. Again they have declared the result or the outcome. What happened with this genetically modified mosquito? Because they do not have any side effect. But now here again in the passage it is given it is remain to see. That means we are waiting. But now here in the option they have declared the result, so we can also cancel out this option B. Now let's move to the option C. Option C says both using genetically modified mosquitoes and chemical have undesired consequences and can be dangerous. Now again they have given some sort of, they have declared the reason because they have given this chemical and genetic both approach have undesirable consequences. Again it is wrong. So the same reasoning we can, now the last option is D, and also again it must be correct. Option D says using chemical to kill mosquitoes may have undesired consequences. Yes, it is simply this first statement. Using chemicals to kill mosquitoes may have undesired consequences, but it is not clear if using genetically modified mosquito have any negative consequences. Now here this word is important, but it is not clear. That means we are not sure what happened with this novel approach, with this genetic engineering. That means we are not 100% sure whether this process give the positive outcome or negative. So simply we can say option D is the correct statement that we can say from the above passage. Let's move to the next question. Okay, question 7 says consider the following inequalities. So now we have two inequalities, 2x minus 1 must be always greater than 7 and 2x minus 9 must be always less than 1. Which one of the following expression below satisfy the above two inequalities? Now simply we have to find the range of this variable x in such a way that those two inequalities must be satisfied by this variable. So now here let's start with this our first inequalities. So first inequality says 2x minus 1 must be greater than 7. So now I can add 1 on the left hand side and right hand side. So I can write this inequality is exactly same as 2x is greater than 8 because we are adding 1. So here this negative 1 is cancelled with plus 1 and here 7 plus 1, so 8. So we can say our variable x must be greater than 4 according to first inequalities. Now let's move to this second inequalities. So second inequality says 2x minus 9 must be less than 1. So now again we can add 9 on the left hand side and right hand side. So our left hand side will be 2x less than 10. So again we can say our variable x must be less than this 5. So now we have find out two conditions for this variable. So one can easily say if our variable is greater than 4 and less than 5, that means our this variable is trapped between those two numbers 4 and 5. So we can say our variable this x, it can be greater than 4 but it must be less than 5. But now here we cannot put equal to here because here in the inequalities they have given the less than and greater than sign. Simply we can delete this 4 and 5 from this range. So our x can take any value between 4 and 5 but it will not take this 4 and 5. So now let's draw this inequality in this xy plane so you can easily visualize it. So now here it is nothing but our x-axis and here it is our y-axis. So we can say x-axis and y-axis. So now first inequality says our x must be greater than 4. So now here we have 4 somewhere here. So we can draw vertical line here to represent x equal to 4 in this way. So now here this line is nothing but x equal to 4. And now here according to first inequality our x must be greater than. That means I have to move right from this line to make variable as greater than 4 because we know x-axis is positive in this direction. So now here we have 5, here 6, the same way it goes to infinity. So we can select any value which is greater than 4. So now let's use this second inequality. So second inequality says x must be less than 5. Again here the 5 is here. So we can also draw a line here to represent x equal to 5 this way. And now this inequality says x must be less than 5. That means we have to move to the left because x is decreasing in left direction and is increasing in the rightward direction. So simply we can say the common area for those two conditions is nothing but is trapped between those two lines, this one, this area. So I can say our variable can take any value between 4 and 5, but now here we must have to delete this point 4 and 5. So simply we can put this hollow circle here to represent this value is not included in this range. So now from the option we can say option C correctly describe the condition for this variable x to satisfy this both inequalities simultaneously. So you can say option C is the correct one. Okay, so now let's solve question number 8. So question 8 says 4 points P, Q, R, S, and we have given the coordinate of all the 4 points represent the vertices of a quadrilateral. Now here again this word quadrilateral is nothing but the simply figure with 4 sides and 4 corners, and we have given the coordinate of these 4 vertices is P, Q, R, S. So they are asking what is the area enclosed by this quadrilateral. Now simply let's try to draw this quadrilateral with the help of these 4 vertices. So now let's first of all set up our coordinates axis. So I can say here we have drawn this xy plane. So it is nothing but our x axis, and here this is our y axis. So now let's first of all locate this first coordinate which is named as P. Now P has coordinate as 0, 1. That means our x value has 0 and y value is 1 unit. So we can say somewhere here simply on the y axis. So we can say this point is nothing but the P, and it has coordinate of 0, 1. Now let's move to the second coordinate. The second coordinate here, sorry, second vertex, and second vertex is Q, and it has coordinate of 0, negative 3. Again, x is 0 and y is negative 3. So now we are below the origin, but now still we are on the y axis. So now here somewhere, let's call this point as Q, and the coordinate of this point is nothing but 0, negative 3. Okay, so now let's move to this vertex R. Now again R has coordinate of negative 2, negative 1. That means our x value is negative 2. So now we are on the left side to the x-axis, and again we are below the origin for this y value because y is negative. So somewhere here, so we can say this point is located in this third quadrant somewhere here, and it is named as R. It has coordinate as negative 2, negative 1. Now the last vertices of this quadrilateral named as S, and here the S has coordinate as plus 2, negative 1. So now here we are on the right hand side of this x-axis, and we are still below the origin for this y-axis because again the y is negative here. So now here this point is fall in this fourth quadrant of this SY plane, and we can say this is nothing but our simply S, and it has coordinate of 2, negative 1. So now to find out this quadrilateral, let's connect all 4 vertices. So now simply let's draw the line to connect all 4 points here in this xy plane. So now here our quadrilateral look like this. So now it look like square, but now we are not sure whether this angle is 90 degree, and the length of this whether it is square of the rectangle or some parallelogram. But now simply what we have to do, the next step is that we have to find the dimension of this all edges. Let's call it d1, d2, d3, and d4. Now once we find out the dimension of this d1, d2, 3, 4, and this angle, we can say what is this figure look like, and we can easily find this area of this figure after finding these angles and this dimension. You can also directly find this area by the vector notation. Simply we have to divide this square into 2 parts. First part this little triangle here, this one with P, R and Q, and the second triangle is P, Q and S. So simply we can find the area of this individual 2 triangle and simply we can add. But now here it is easier to find the distance of this between those 2 points. In the other word, the dimension of this length of this quadrilateral. So now let's start with D1. So now here D1 is nothing but the distance between those 2 points here, this point and this point. Now here from the basic concept we know the distance between any 2 points in the xy plane is nothing but the simply magnitude of distance is under root of the difference of x coordinate x1 minus x2, and we have to square it plus the square of difference of the y coordinate. So we can say y1 minus y2, and we have to again square it. So now with the help of this formula, we can easily find the distance of this d1. So now let's find it here. So we have to put this under root sign, and here our x coordinate is 0 here, and here negative 2. So we have to subtract negative 2 from 0. So it will turn out to be plus 2, and the square of 2 is 4. and plus we have to again add the square of the difference of y coordinate. Here the y coordinate is 1 and here is negative 1. So again 1 minus minus 1. So it will again give plus 2 and the square of 2 is again 4. So you can say d1 is nothing but simply under root of 8. Now in the same way you can say d2 is nothing but the distance between the this vertex P and S. So simply the same equation. We have to subtract this coordinate, this coordinate from this one, or in the other one, we can also do in the reverse one. We have to subtract this coordinate from this one. So let's subtract this 0 from 2. So again we are getting x, this difference of this x coordinate as 2, and the square of 2 is again 4, plus we have to find the difference of the y coordinate. Here the negative 1 minus 1. So again it will turn out to be negative 2, and we have to square it. So again it will turn out to be 4, simply under root of 8. The same way d3 is nothing but the distance between this S and Q vertices. Simply again the difference of x coordinate here is 2 and 2 square will be 4, plus the difference of y coordinate here negative 3, negative of negative 1, so it will be plus 1. So negative 3 plus 1, it will again negative 2 and the square is 4 here, and the sum of those two numbers is again 8, and last distance is d4. Simply again we have to subtract the x coordinate here from here. So we can say again we are getting 4 plus negative 1. Now here negative 1, negative of negative 3 for this y coordinate. So we can say negative 1 plus 3. Again it will turn out to be 2 and 2 square will be again 4. So again this dimension is also under root of 8. So now you can easily see all the edges of this quadrilateral are same, under root of 8, under root of 8, under root of 8, and here also under root of 8. So now we can say here with this property our quadrilateral will be square, then and then all the edges are equal. We know from the property if all the edges are equal for any quadrilateral, then it will be nothing but simply square. Here under root of 8, under root of 8, under root of 8, under root of 8. But now here this square is tilted somewhere in this xy plane, so now it will look like this one. But now here the area is remain nothing but simply the area of this square with side of under root 8. So we can say area is nothing but under root of 8 multiplied with under root of 8. This side multiplied with this one for the square. So we can say area is nothing but simply 8. Now we have find out the area, which is nothing but the inner portion of this quadrilateral. This one, it represents our area. So now from this property, for all the sides are equal, we can say this angle is 90 degree. We can also prove this angle is 90 degree with the help of dot product. Simply we know the dot product of any two vector. Let's say we have vector v u and vector v, and we are taking the dot product of these two vectors. So we can equate this dot product equal to the multiplication of magnitude of these two vectors and the cosine of angle. Now here the angle is theta. Let's assume, we are not sure whether they are, because we are proving this angle is nothing but the 90. So let's simply assume it is nothing but the theta. But now we need two vectors u and v. So now simply our two vectors, we can easily find the vector from this point. So now here we can shoot the arrow in this way to make our first vector. Start from the point R and go to this point P. So its tail will be on the R and head will be on the P. In the same way, we can also shoot the arrow in this direction to reach at this point. And here this tail is again on the R and this head is again on the Q. So we can easily find this vector RP and RQ. So let's quickly do it here. So vector RP, we have to denote this vector with the arrow on top, because it is vector and the vector has two things. One is magnitude and second is direction. So now simply we put the arrow here to distinguish it is vector. So now here simply we have to subtract the coordinate for this point P, for coordinate of this R from this point P to find this vector RP. Simply here the coordinate is 0, so we have to subtract negative 2 from 0. So it will turn out to be plus 2. In the same way we have to subtract negative 1 from this one. So again it will 2. In the same way we can also find this vector RQ. Again here we have to subtract the coordinate of this R from the coordinate of this point Q. And here 0 minus minus 2, it will again plus 2, and here negative 3, and we have to subtract negative 1, so it will turn out to be negative 2. Now simply we have to take the dot product of those two vectors. Now here dot product is nothing but simply the multiplication of those two numbers plus multiplication of this y coordinate. So we can say multiplication of those two numbers for the x coordinate is 4, and the multiplication of y coordinate for the two vector is negative 4. So we can say here the dot product is turned out to be 0, and we can equate this 0 equal to this magnitude of this u and v. Now here this magnitude is non-zero, it cannot be 0. The same way we can say this magnitude is, it can not 0. So simply this cosine of angle must have to 0 to satisfy the left hand side. So we can say cosine of theta equal to 0, and we know the cosine of 90 is nothing but 0. So we can say theta is nothing but 90 degree. Hence we prove this quadrilateral is nothing but simply square, because this angle is turned out to be 90 degree. So this quadrilateral with these four vertices is nothing but simply square tilted in some xy plane. Now here we can say with some angle here. Now let's move to the question 9. Okay, 9. Question 9 says in a class of 5 students P, Q, R, S and T. Now here this P, Q, R, S, T is nothing but the 5 students. Only one student is known to have copied in the exam. So now here out of these 5 students, it is known that only one of the students from those 5 students has copied in the exam. The disciplinary committee has investigated the situation and recorded the statement from the student as given below. Now here this investigating committee come into the picture, and they recorded the different statement from those 5 students to find out which student has actually copied in the exam. Now the statement of this student P. So P says R has copied in the exam. Q says S has copied in the exam. R says P did not copy in the exam. And the student S says only one of us is telling truth, and T says R is telling truth. So now here the question has further information. The investigating team had authentic information that S never lied. Now here this line is important. Now here this investigating committee has had authentic information that this committee is 100% sure that student S will never lie. That means whatever the statement that is given by student S must be true, because this is the condition that this investigating committee know. So we can say the statement of this student P must be true. So now we have to make this statement true. So now here the first condition is that this statement is true, and now we are moving to the statement. What is the statement actually? So now this statement says only one of us is telling truth. So now here two things are combined. First, committee has confidence that this student S is true. That's mean we have assumed, that mean committee has sure that this student is true, and now the statement of the student itself is giving that only one of us is telling truth. Now committee has had already authentic information that S never lie, and the S is says only one of us is telling truth. That's mean only the student S is telling truth, because the statement of student S is itself is describing that the only student which is giving the statement is true, and the remaining four students are false. So we can say only one statement, because the statement of student A says only one of us is telling the truth. So now pause the video and think yourself, so you can easily find the statement itself is saying that this only the student S is telling truth. So we can say this only statement is true, and the remaining four statements are false. So now let's read again the statement of student P. Student P says R has copied in the exam. So now here this statement is true. So now we can say R has not copied in the exam. That will be true. We have to make the opposite statement to make it true. So we can say R has not copied in the exam. So we can cancel out this R. So we can also cancel out this option A also. Now the statement of Q says S has copied in the exam. Again this statement is false. So we can say S has not copied in the exam. So S has not copied in the exam. So we can also, now here in the option S is not given. So now let's move to the option R, sorry, statement R. So statement of R student says P did not copy in the exam. So now here this statement is false. That means we have to reverse it. So we can say P has copied in the exam because this statement is true. Sorry, this statement is false. Then the opposite of this must be true. So we can say opposite of this statement is nothing but the P has copied in the exam. So we can say P is the student that has copied in the exam. Now let's also check for this statement of this student to T. So T says R is telling truth. Now again this statement is wrong. So now again we have to reverse it. So R is not telling truth. Now here this condition is satisfying with this one because we already know this condition is false and this condition is also false. So we can say the opposite of this is R is not telling truth. So whatever the statement of R is must be false and the statement of R is P did not copy an exam. So we know this statement is false. Then we can say the student P has copied in the exam. So option B is the correct student that has copied in this exam. Now let's move to the last question for this video. Question number 10. Okay, now let's solve question number 10. So question 10 says, consider the following square with four corners and the center marked as P, Q, R, S and T respectively. So now here this P, Q, R, S are nothing but the four corners of this square and this T is nothing but the center of this square. Let X, Y, Z represent the following operation. Now here this X, Y, Z is nothing but the specific operation and this what is that operation is defined in the question. So x is nothing but the operation that rotation of a square by 180 degree with respect to sq. That means the diagonal of this square represented by this sq. The operation x is that we have to rotate this square with about this diagonal by 180 degree. Operation y says rotation of square by 180 degree with respect to PR axis. Now here the rotation is by the same amount, but now here we have changed our reference axis, and here the reference axis is this second diagonal PR of this square, and the last operation which is represented as Z, and Z says the rotation of square by 90 degree clockwise with respect to the axis perpendicular going into the screen and passing through the point T. Now here this operation Z is nothing but the rotation of this square by 90 degree in a clockwise direction with respect to the line passing through this point T, which is the center of square and which is perpendicular. That's mean it is going and coming out from this screen. Now consider the following three distinct sequence of operation which are applied in the left to the right. Now here we have four sequence and here this sequence is decoded in this x y z z x y and z z z. And now here we have applied this operation in the specific direction and the direction is from left to right. That means we have to first apply this x operation, then y, then z, then z. Now for this second sequence we have to first apply x operation, then y, and for this last sequence we have to apply this z first, again z, again z and again z operation. So now let's start with the first sequence. So I can write here 1 and here our sequence is nothing but x, y, z, z, and here this x is nothing but the represent this operation. So now first of all let's draw our basic figure which is given in the question. So now here our figure is look like this. So it is square and it has named as P, Q, R and S. Here the center of this figure is denoted as T. So now let's apply this x operation. We are applying the operation x on this figure. Here this x. So now here again let's read the description for this x operation. X operation is nothing but the rotation of square by 180 degree with respect to this SQ axis, here this one. So now here simply we have to rotate this square by 180 degree about this SQ axis, here this SQ axis. So now here this Q will be come at this point and S will come here. In the same way this P will come here and R will goes there. But now here the condition is not given in the description of this x operation whether this 180 degree turn is clockwise or anti-clockwise. So now here in this figure we have rotated this figure in this direction, that means clockwise. So we can say here we have taken the 180 degree turn clockwise. So now let's also take the anti-clockwise turn. turn of 180 degree. So we can say counterclockwise. Sorry, here clockwise direction CD and here CCD. That's mean counterclockwise direction. So now again we have to take the 180 degree turn with respect to this SQ diagonal. But now here the direction is opposite in this way 180 degree. So again this Q will come here and this S will come here. Again this R will be there and again this P will be here. But now notice the figure that we are getting in the top and the bottom, they are exactly identical. That's mean it not make any difference whether we are taking this 180 degree turn clockwise and anti-clockwise, because those two figure after taking this 180 degree clockwise turn and 180 degree anti-clockwise turn are exactly same. So we can equate those two. So now we have performed this X operation. So now the next operation is Y operation. This one is Y. So simply again we have to apply operation Y on this figure. Again let's draw our square, because square will be remain square but the corner will be changed after applying the operation. Now here this Y operation says the rotation of square by 180 degree with respect to the PR axis. Now again we have to rotate this square with this PR axis. That means this second diagonal 180 degree. So now here this P will come here, this R will goes there and this S. Okay, so we can say this P and here this point is nothing but the S and this point is Q. Okay, so now we have applied the R operation. Now again you can also take the, we have taken the turn 180 degree in the clockwise direction. You can also take anti-clockwise direction and you end up with the same figure. Let's again do it here for this operation Y also. So now here this bottom figure is nothing but the 180 degree turn in the anti-clockwise direction from this figure with respect to this RP diagonal. So again this point will be P, this will be R, again this will be S and this will be Q. So again you can see those two figures are exactly identical. So now here it does not make any difference whether we are taking this 180 degree turn anti-clockwise or clockwise. So now we have applied this R operation also and we end up with this figure in this color. So now let's apply the Z operation, this third operation which is nothing but the Z operation. So now we have to apply the Z operation on this figure, and the operation Z says the rotation of a square by 90 degree clockwise with respect to the axis perpendicular to the screen passing through the point T. Now here this intersection of those two diagonals is nothing but the center, and the operation Z says we have to rotate this square by 90 degree in the clockwise direction about the center point here, about this point. So now let's rotate this figure. So P will come here, Q, R and S. Now here our figure will look like this after applying this Z operation. Now again we have to apply one more Z operation, because in the sequence once we have twice Z here. So let's again apply this Z operation. So now our final answer for the first sequence will be look like this one. Here this will be S, this will be P, this will be Q and this will be R. So now we have find out the answer of this first sequence. So let's denote it with 1 because it is the answer of this first sequence. So now we have to do the same thing with the remaining two sequence number 2 and sequence number 3. So now let's move to the sequence number 2, and the sequence 2 says we have to apply first X and then Y. But now here look at this sequence 1. This portion is common because we are applying this XY in the first sequence first, and we end up with this figure. So now simply we can directly paste this figure here, because the output of this XY operation is nothing but this one, because we have already applied this two operation to finding the output of this first sequence. So now simply we can copy paste the outcome for this sequence to save our time. So here our figure will look like this: P, Q, R, S. Here this figure I have copied here. So now let's move to the last sequence, which is nothing but the sequence number 3. And sequence 3 say we have to apply this Z operation 4 times. And now here this Z operation is nothing but the rotation of this square 90 degree count clockwise with respect to this center point T. So now here let's draw again our base figure. So this point is P, Q, R, S, and again let's apply Z operation. Now here one can directly say from this figure, because Z is nothing but the 90-degree turn, and whenever we are turning 90-degree 4 times, then it will complete one full circle. That means 90 plus 90 plus 90 plus 90. It will give 360. So we can say 90-degree turn plus 90-degree turn plus 90-degree turn plus again one time 90 degree. It will give 360 degree. So now we have completed one full revolution of this figure. So simply we can say, after taking the 4 times Z, we are end up with the same figure, because we are completing the one whole circle. So you can say we are getting this result PQRS. You can also do by applying first time Z. So simply this P will, let's quickly do it here. So now applying the first time Z, so this will PQRS. So now here it is, we are applying first time Z. Now let's again apply Z to this figure. So I am doing it quickly, so my figure will be not perfect square. So but now again let's apply this Z operation further, and we are applying third time. So it will turn out to be R, S, P, Q, and the last time we have to apply this Z, and we end up with P, Q, R, S, which is exactly same as this one, green one, which is initial one. So we have applied 4 times Z, first time, second time, third time, and fourth times. That means which is nothing but our this third sequence. So now look at the option. Now here this is the result of second sequence. So we can mark as 2, and this green one, last one, is nothing but the result of our third sequence. So now observe the result of three sequence. You can see here the result of this second sequence is exactly identical as this third one, because the here we have P, Q, R, S in that direction, in this direction. You can also see we have the same notation for this figure also, P, Q, R, S. But now here look at this first outcome of this first sequence, which is R, S, P, and Q. So it does not match with any two of these 2 and 3. So we can say this sequence 2 and 3 are equivalent. So we can say the sequence 2 and 3 are equivalent. So now look at the option. Option C says the sequence of operation 2 and 3 are equivalent. So we can say option C is the correct answer, because the result of this sequence 2 is exactly identical with the result of this third sequence. And thanks for watching this video. If you enjoyed the video, then like, share, and subscribe to the channel, and share this video also with your friend. See you later on the next video. Till then, take care of yourself, and bye bye.